Have you ever wondered how a car accelerates, why a train takes time to stop, or how we calculate the exact position of a moving object? Every one of these questions begins with one fundamental chapter, which is motion in a straight line. In this video, we will build this chapter from basic, covering every important concept, solving questions, and focusing on the tricks that will help you crack NEET. So grab a notebook and let's get started. Kinematics. This basically deals with the study of motion without considering the cause. It considers every object irrespective of its sizes as point masses. So irrespective of the sizes, they consider each object as your point masses. It's important to describe 6 important terms which would be used in this chapter, which are your time, distance, speed, displacement, velocity, and your acceleration. These 3 terms are considered as your scalar quantity, which only deals with magnitude, whereas these 3 are considered as your vector quantity, which deals with both magnitude and direction as well. So moving on to distance and displacement. Distance is basically the total path of the length. As you can see in this image, this is your start point and this is your end point over here. So the total path of the length is called as your distance, whereas if you see displacement over here is the shortest distance from the initial and the final position. So if we define distance is basically the total length of the path. Talking about the SI unit of distance, so the SI unit of distance is your meter, and as mentioned above, this is your scalar quantity. Moving on to displacement. So displacement is basically only interested in the initial and your final position. It has the same SI unit as that of distance, which is your meter, and here this is your vector quantity. Some things to keep in mind is that distance can never be 0 or negative, whereas displacement can be positive, negative, or even 0. And yeah, the final thing is that distance will always be greater than equal to the magnitude of displacement. Moving on to speed and velocity. We all know your speed is the distance traveled upon the time taken. And an important conversion which you need to keep in your mind is that 1 km/h is equals to 5 by 18 meter per second. If you want to know how did it come, so basically 1 kilometers is 1000 meters and 1 hour is 60 times 60 seconds. So cancelling out the zeros and dividing this by 2, we get it as 5 by 18 meter per second. And yeah, defining velocity. Velocity is basically displacement upon your time taken. Okay, so there are two examples which you need to keep in mind. Example number 1, let's say if they mention a particle travels first half distance with speed v1 and second half distance with speed v2, find its average speed during the journey. Let's consider these half as your distance s and s. So we need to find your average speed. Average speed we all know is total distance upon total time taken. So your total distance from A to B would be your s plus s, which would be your 2s upon time taken. Time would of course be s by v1 plus s by v2. Okay, so 2s upon, if we try to make the denominator same, let's first take s common. We'll get 1 by v1 plus 1 by v2, cancelling off the s, and we get 2 upon v2 plus v1 upon v1 v2. So when this goes up, we get 2 v1 v2 upon v1 plus v2. This is basically your harmonic mean. We'll have to use this formula when equal distances are given. Okay, we'll have to keep this in mind. When equal distances are given, we'll have to use the formula 2 v1 v2 upon v1 plus v2. The second case is that if a particle travels with speed v1 during first half time interval with speed v2 during the second half time interval. So when equal times are mentioned, then what will you do? Average speed is basically your total distance upon total time taken. So total distance would be v1t plus v2t upon total time taken would be your t plus t. Taking t common, v1 plus v2, and this would be 2t, cancelling out the t, we get v1 plus v2 by 2. This is basically your arithmetic mean, and we'll use this formula when equal time intervals are given. Moving on to acceleration. Acceleration is basically your rate, it's basically a rate of change of velocity. This is your vector quantity as well. Writing its formula, acceleration is your velocity upon your time taken. When they mention uniform velocity, so uniform velocity basically means that your acceleration is 0. Okay. Equations of motion. There are 3 standard equations of motion which we need to keep in mind. Before telling you the equation of motion, it's important to describe few terms like your U, V, A, S and T. What U stands for is your initial velocity, V stands for your final velocity, A stands for acceleration, S stands for your distance traveled, and T stands for the time taken. So the three standard equations of motion are your V is equals to U plus AT. Second one is your S is equals to UT plus half AT square, and the third one being your V square is equals to U square plus 2AS. Okay. There's a fourth one which can be used in some cases, is basically used to find the distance traveled at nth second. The formula for this is Sn, the distance traveled in the nth second, would be the initial velocity, that is u, plus a by 2 into 2n minus 1, where your n is the nth second. Like, let's say for example, if they say find the distance traveled at the 5th second, then you would put your value of n as 5. Okay, let's solve some questions so we'll understand this, how you have to use the formula. Let's take this question. A body starting from rest. So as you can see, the question says starting from rest, which means your initial velocity, that is u, would be equals to 0 and attains a velocity of 20 meter per second. So your v is equals to 20 meter per second in 30 seconds, and your t is 30 seconds. Find its acceleration and the distance covered in that time. They are asking us to find your acceleration, which is a, and distance, which is s. So if you use the first equation of motion, that is v is equals to u plus at, initial velocity is 0 and we need to find a in this question. V is already given, that is 20 is equals to a times 30. So your acceleration will come out to be 20 by 30, that is 2 by 3 meter per second square. Second, they have asked us distance. So we'll use S is equals to ut plus half at square. U is 0. So we'll get this as half times acceleration times time square, which is 30 times 30. 2 will get cancelled, 3 ones are 3 tens are. So your distance would come out to be 300 meters. Let's solve another question. A particle traveling in a straight line has an initial velocity of 4 meter per second and a constant acceleration of 8 meter per second square. Find the distance traveled in the 5th second. Okay, so we'll have to use the fourth equation which I told you. Let's first write what's given to us. We have been given the initial velocity, which is 4 meter per second, and acceleration, which is 8 meter per second square. Find the distance traveled in the 5th second. So the value of n given in the question is 5. So we'll have to use the formula, which is your u plus a by 2 into 2n minus 1. Initial velocity being 4 plus 8 by 2 into 2 times 5 minus 1, which will be your 4 plus 4 times 9, 4 plus 36, which is 40 meters. Okay, let's move on to some graphical representation of one-dimensional motion. We'll start with your position time graph, where your time would be on your x-axis and displacement would be on your y-axis. Okay, so the first graph, where you have a straight line, what does this indicate? This means that with time your displacement is same, or your distance is same, which means that your particle is at rest. The second graph, where you have a straight line like this basically means that at equal intervals of time distance is being covered, which means that your velocity of the particle is constantly increasing. And your third graph is like this, where you can see with increasing time your distance is decreasing. So in this case your velocity is constantly decreasing. Moving on to your next, which is your velocity time graph, where velocity is in your y-axis and your time is in the x-axis. Your first graph, which is a straight line, this basically means that your velocity is remaining the same with respect to time. So you can say that you have an uniform motion, or your acceleration is 0. Second case, you have a straight line, then you can say that this is a uniformly accelerated motion, and your acceleration over here is constant. Your third graph would be like this, where you can see that acceleration is increasing with time. Your fourth graph is like this, where your acceleration is decreasing with time, or you can say that the body is retarding. And your last graph being your this, where you have an uniformly accelerated motion, but the acceleration is decreasing with time. So acceleration is uniformly decreasing with time. Moving on to your acceleration time graph, and yeah, one thing I forgot to mention is that the area under the velocity time graph gives you displacement. I'll write over here area under the velocity time graph will give you displacement. Like let's say for example, if they ask the displacement in this case, the area which is enclosed by the graph will give you your displacement. Moving on to acceleration time graph. If you have a straight line, this basically means this is an uniformly accelerated motion, and the area under the acceleration time graph will give you velocity. Okay. Another graph would be this, where acceleration is increasing with time. Acceleration is increasing with time, and this would be your third graph where acceleration is decreasing with time. Moving on to motion under gravity or free fall, where one thing you need to keep in mind is your g, which is called as your acceleration due to gravity. Acceleration due to gravity, and the value of g, okay, the value of g is taken to be 9.8 meter per second square, and this value is found in all the bodies irrespective of their sizes or their weight. Moving on to the different cases of motion under gravity, which this one being your first case, that if a body is projected vertically upwards from the ground, this is considered as a ground frame, and a body is projected vertically upwards, it will gain some height and it will reach a point where its velocity would be 0 and would again fall down. So talking about the equations of motion over here, you can see that the motion of the body is vertically upwards, but acceleration of gravity, which is a g, always acts downward. So the acceleration in this case would be negative, as the motion and acceleration are opposite in direction. So your first equation of motion would be v is equals to u. Instead of plus, we'll have a minus over here, minus, and acceleration will be considered as g over here. So v would be equals to u minus gt. Let's say it reaches a height h, so then h would be equals to ut minus half gt square, and your third equation being v square is equals to u square minus 2gh. Okay, let's say it reaches a maximum height where your final velocity would be equals to 0. Then using v is equals to u minus gt, your v is 0, then you get u is equals to gt. So your time comes out to be u by g, which means the time required from ground to the highest point, or to reach the maximum height, is u by g. This is also called as your time of ascent, and the time required for the body to come down would be same, u by g, which is called as the time of descent. So your total time period would be your time of ascent plus your time of descent would be u by g plus u by g, which is equals to 2u by g. This is an important thing which you need to keep in mind. So the total time period when a body is projected vertically upwards is your 2u by g, and if you put the value of v over here, 0 is equals to u square minus 2gh, u square is equals to 2gh, and the maximum height which a body gains is your u square by 2g. This is also an important thing which you need to keep in mind, that when a body is projected vertically upwards, the maximum height it gains is the initial velocity square divided by 2g. Moving on to the next case, that if a body is dropped from some height, if it is dropped, which means that your initial velocity is 0. As you can see over here, it is being dropped from a height h. In this case, we all know u is equals to 0, and the direction of the motion is in the same direction as that of your acceleration due to gravity, so it would be considered positive. So acceleration we all know is plus g, so v would be equals to gt as your u is 0, and your distance h would be your half gt square, so the time required would be equals to under root of 2h by g. This is also an important thing which you need to keep in mind, that when the body is dropped, the time required to reach the ground would be under root of 2 into height divided by acceleration due to gravity. The key point over here is that the distance covered in the first, second, third and so on seconds are in the ratio 1:3:5:7:9 and goes on, which basically means that the distance covered are in the ratio of the odd integers only. Okay, it's basically like 5 meters in the first second, 15 meters in the third second, 5 in the first second, 15 in the second second, and 25 meters in the third second, and go on. This goes on. Moving on to, if a body is projected vertically downwards with some initial velocity from some height. In the case before this, we saw that a body was dropped, so the initial velocity was 0. But in this case, you're projecting it vertically downwards, so you're providing some initial velocity to it. So this would be same. V would be equals to u plus gt. Acceleration would be positive as the direction of motion, and acceleration due to gravity are same. H would be equals to ut plus half gt square, and v square would be equals to u square plus your 2gh. Moving on to the next, which is if a body is projected vertically upwards with some initial velocity from a certain height, which means you're projecting vertically upwards from some certain height, capital H. So it will reach a point where its final velocity would be 0. It would have gained some height, let's say small h, and then it will come down. So here we have to take the initial velocity as negative, so v would be equals to minus of u plus gt. Your height, capital H, would be minus of ut plus half gt square. Talking about the maximum height attained by the body, let's take h max. H max would be, of course, your capital H plus your small h, where your small h would be your u square by 2g. I told you over here, in this case, when a body is projected vertically upwards, the maximum height it gains is u square by 2g. So using it over here, we get h plus u square by 2g. And if they ask distance traveled by the body, would basically be your h plus your capital H, which would be your h plus 2h, which is your u square by 2g times 2. Your 2 will get cancelled, and this will come out to be h plus u square by g. This is basically a distance traveled. If a body is thrown vertically upwards, if constant air resistance is to be taken into account. We'll have two cases. First would be your upward motion. For upward motion, when a body is being projected upwards, your motion is upwards, so acceleration of gravity being g will act always downwards, and as your motion is upwards, air resistance would try to resist your motion, so your air resistance would also act opposite. One minute. Yeah. Your air resistance will also act opposite to that of the motion, so it will act an acceleration downwards. So your net acceleration over here is your g plus a downwards. So the time required to reach the maximum height over here would be under root of 2h by a net, where your net acceleration over here is g plus a. The second case is for your downward motion. The motion of the body is downwards. The acceleration of gravity, we all know, always acts downwards, and the air resistance will try to resist the motion, so it will act vertically upwards. So here your net acceleration would be g minus a. So the time required to reach the ground would be under root of 2h upon g minus a. Okay, and yeah, one thing to keep in mind, that your time of descent, that is the time required to reach the ground, would be greater than your time of ascent. Why? Because you can see this is your time for descent and this is your ascent. Here the denominator is less because there is subtraction, the denominator would be less and hence your time would be more, and here the denominator is more, so your time would be less, hence time of descent would be greater than your time of ascent. Let's solve some question. I guess there's only one question. I'll basically solve your PYQs and other questions in the next video. For now we'll have only one question over here because I guess the length of the video would be too long for you guys to see. So we'll just solve this one question and wrap it up. A body is projected upwards from the top of a tower 175 meters high with a velocity of 10 meters per second. Find the time taken when it strikes the ground. So let's draw and see what's given in the question. A body is projected upwards from the top of a tower 175 meters high. So it basically says that your tower is 175 meters high and you're projecting a body vertically upwards with an initial velocity of 10 meters per second, and they're given in the question that take the value of g as 10. Find the time taken when it strikes the ground. Okay, so your acceleration is your minus g, which is minus 10 meter per second square. Your distance s is minus 175 meters. Using your s is equals to ut plus half at square, we get minus 175 is equals to 10t minus half a t square. So we got a quadratic equation over here. Minus 175 is equals to 10t minus 5t square. We'll take this over here. So 5t square minus 10t minus 175 is equals to 0. Dividing this by 5t square minus 2t minus 35 is equals to 0. We'll have to take two factors whose multiplication would be 35 and the difference of 2. We have 7 and 5 over here. So t square minus 7t plus 5t minus 35 is equals to 0. Taking t common, t minus 7 plus 5, t minus 7 is equals to 0. So t plus 5, t minus 7 is equals to 0. So we get the values of t as 7 seconds or t is equals to minus 5 seconds. As the value of time can never be negative, so the answer to this question would be t is equals to 7 seconds. So that's it for today's lecture on motion in a straight line. I hope this helped you understand the concepts clearly. In the next video, we'll solve some important PYQs and questions from this chapter, so make sure you don't miss it. If you found this video helpful, don't forget to like, share and subscribe. Thanks for watching and I'll see you in the next one. Bye.